Welcome to this quick demo of the timestamping window in version 1.3.0 of Tempico Software. Tempico Software is a desktop application designed to control Tempico devices, which are high-precision time-to-digital converters. Through its graphical interface, the software enables hardware configuration and the acquisition of temporal event data. Its main features include start-stop histograms, lifetime histograms, and count estimation of any of its stop channels. A new feature called timestamping has been added in version 1.3.0 of the software. This functionality allows users to capture the maximum number of events arriving at the Tempico of any of the stop channels. Additionally, events that include only a start are also recorded. Users can access the latest 50,000 data entries in the table on the right. However, to optimize resource usage that this visual element may require, the user can choose to disable the table if desired. This window provides three measurement modes: manual, scheduled, and by sample size. It also includes a panel displaying the number of measurements taken so far on each channel and a status bar indicating where the measurement is running correctly or if any channel is experiencing issues. Finally, it offers an autosave option, which will be explained in more detail afterward. The other Tempico windows store measurement data in the same memory used by the program to run, namely the RAM. Therefore, when performing a large data acquisition, there is a risk that the memory may become saturated and all stored data could be lost. These windows are not designed to handle millions of data. However, the timestamping window can easily exceed this amount within just a few minutes. To prevent RAM overflow, the autosave function was implemented. This feature periodically transfers data from RAM to the hard drive, freeing NAC memory and safeguarding all data in the event of an external error. In this tab, any type of signal that the Tempico device can detect and transmit to the software can be measured. However, there are certain restrictions. The first restriction is that a start event must always occur before a stop can be measured. If this doesn't happen, stop events will not be recorded. However, if a start occurs without a corresponding stop, it will be recorded correctly. To identify this scenario, the software displays only a start and the stop value will be -1. The issue arises because Tempico, when registering a single start, waits for a stop to arrive. Therefore, if high-frequency signals are captured using only start events, several pulses may go undetected. On the other hand, in the ideal scenario where both starts and stops are received, start events can be captured more frequently as stops are registered. However, Tempico doesn't register a start instantaneously after a measurement, as it needs to wait a few milliseconds before initiating a new measurement. The maximum and minimum accepted times between start and stop depend on the device configuration mode. To clarify, the following values are only valid for the Tempico TP104. In mode 1, the minimum time is 12 nanoseconds and the maximum is 500 nanoseconds. In mode 2, the minimum is 125 nanoseconds and the maximum is 4 milliseconds. The start resolution is 1 microsecond and the stop resolution is 56 picoseconds. This is reflected in the software where the start is displayed as a timestamp with microsecond resolution and the stop as a picosecond value corresponding to the time elapsed since the start. This tab is useful when a measurement following statistical behavior is desired. To model it correctly, many measurements are required, because although some events may be lost, this will not significantly affect the overall data distribution. If the goal is to record all possible events without losing any, Tempico is limited by the restrictions mentioned above. We will now perform a brief demonstration of how to carry out a measurement in this tab. The first point to consider is that any configuration applied to each individual channel will directly affect the data acquisition. Likewise, the settings applied to the general device will also influence the measurement. Once the desired configurations have been set, we proceed to select the channels on which the measurement will be performed. For this example, we will select channels A and B. Next, we verify that the autosave option is enabled. We recommend keeping it active at all times and setting the minimum interval to avoid data loss. First, we will perform a manual measurement. In this mode, the user starts and stops the acquisition whenever desired. If autosave is enabled, before starting the measurement, the software will prompt for the format in which the data will be saved. For this example, we will select TXT. Once the measurement begins, we can observe the table populating with values, while the lower left panel displays metrics showing the total number of recorded events. The user can pause the ongoing measurement, which will stop data acquisition without ending the measurement. To stop the measurement completely, the user must click the stop button. Thanks to the autosave option, the data will be saved automatically and the storage path will be displayed. When the measurement begins, a second countdown will show the time remaining until completion. Once the time elapses, the measurement will stop automatically and the storage location of the data will be displayed. Finally, we will perform a by sample size measurement. In this mode, the user specifies the total number of measurements to be acquired. After clicking Start, the software will again prompt for the data format, and the acquisition will begin. The measurement will automatically end once the specified number of measurements has been reached. If the autosave option is not enabled after completing the measurement, the user must click Save Data and select the desired format to prevent data loss. In this new version, the user can change the destination folder and the prefix assigned to the saved files for each tab. The user can access this folder to review the saved data. Each file contains the applied configurations and 3 columns with the same information displayed in the graphical interface table. If due to an error the measurement doesn't finish properly, the user can go to the installation directory, where a folder named Temp Data can be found. This folder stores the data from the last measurement performed. It is important that the user makes a copy of this data before starting a new measurement, as they will be overwritten. For more information, please visit Tausand.com. Thank you for watching.